Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Nur Alisafa binti Rozaman and my matrix number is 20224539 and 58. This is my team members. The first one will be Nur Safura binti Abdul Hadi and her matrix number is 20224599 and 38. Followed by Nur Hidayah binti Zaid, matrix number is 20224690 and 92. Lastly, Lala Damia binti Karim with her matrix number is 2022x7, 26 and 16. And today we are going to present to you about Newton's law of cooling. To start with, what is Newton's law of cooling? Newton's law of cooling states that a piece of an object losing heat is directly proportional to the temperature difference between the object and the surrounding temperature. As an example, a glass of hot water will cool down faster in a cold room than in a hot room. The next one is the formula that is used for Newton's law of cooling. The derivative of temperature with respect to times equals to K in bracket T minus Ts, where T0 is the initial temperature at time equal to 0, K is constant of proportionality, and Ts is surrounding temperature. What is the use of this Newton's law in real life? The first thing is to estimating time of death. This can be done by measuring body temperature to get postmortem intervals. The next one is, in food industry, the law can be used in the process of cooling hot food by estimating the time it took for food to cool down before storing. Lastly, this law helps creating cooling system by estimating cooling rates of heated components. The last one for me is the advantages of using this Newton's law on a course, as that is our topic choice. As said before, this law can be used to estimate time of death accurately when no witnesses are present. After that, it offers scientific support for forensic proof in court by helping figure out suspect timelines. Lastly, it is a non-invasive and less expensive method than more modern medical tests.
Hi, my name is Nurtaya. So let's proceed with the problem statement. Amina went up for a jog and discovered a dead body near the lake at 7 a.m. A medical team was sent to investigate the body and then measured the corpse's body temperature at 82 degrees Fahrenheit upon discovery. 2 hours later, the temperature had decreased to 76.5 degrees Fahrenheit. Assuming that the temperature of the surrounding is 68 degrees Fahrenheit, estimate. So the first question is, estimate the time of death. Does it suggest the crime happened before or after midnight? So let's identify the known value from the problem statement. Ts equals to temperature of the surrounding area is 68 degrees Fahrenheit. T0, the initial temperature when the body was found, is 82 degrees Fahrenheit, and T2, which is temperature after 2 hours, equals to 76.5 degrees Fahrenheit. dt over dt equals to alpha t minus ts. Replace alpha with constant k and we will get dt over dt equals to k t minus 68. Now we will integrate both sides and we will get ln t minus 68 equals to kt plus c, where c is the constant of integration. We exponent both sides and we will get t minus 68 equals to c e to the power of kt. Step 1. Let's find c using initial condition. At time t equals 0, the temperature was 82. So we substitute that in. 82 equals to 68 plus c e to the power of k0. Then we will get c equals to 14. So then we will get t equals to 68 plus 14e to the power of kt. Step 2. Find k using second temperature. 2 hours later, the temperature is 76.5. We substitute that in with t equals to 2. 76.5 equals 68 plus 14 times e to the power of k times 2. 8.5 equals to 14e to the power of 2k. Ln 8.5 over 14 equal to 2k. And then we will get k equals to negative 0.2495. Get t equals to 68 plus 14e to the power of negative 0.2495t. Let's estimate the time of death. Now we want to know when the person died, assuming that the normal body temperature is 68.6 degrees Fahrenheit. So we said T equals to 68.6. 68.6 equals 68 plus 14 times e to the minus of 0.2495 t. Subtracting 68 gives us 30.6 equals 14 times e to the minus 0.2495 t. Then we will divide both sides by 14. E to the minus 0.2495 t equals 30.6 over 14. Now take the natural log of both sides and solve for t. T equals negative 3.13 hours. That means the death happened 3.13 hours before 7 a.m. 0.13 hours is about 7 minutes and 48 seconds. So the time of death is around 3:52 a.m. That means the crime happened after midnight. So this is the answer for question number 1.
Now, let's move on to the second question. At what time will the corpse reach 70 degrees Fahrenheit? For this question, we will use the same formula we found earlier, which is T equals to 68 plus 14 times e to the minus 0.2495 t. This equation tells us the body temperature at any time t hours after 7 a.m. To find when the temperature reaches 70 degrees Fahrenheit, we set T equals to 70 and we will solve for T. So, we write 70 equals 68 plus 14 times e to the minus 0.2495 t. We minus 68 for both sides, we will get 2 equals 14 e to the minus 0.2495 t. And we will get ln 2 over 14 equals negative 0.2495 t. And we solve for t, we will get 7.7992, which is equals to 7.8 hours. To get hours and minute, we will have to calculate 0.8 times 16. Therefore, we will get 48 minutes. So the time it took for the body temperature to reach 70 degrees Fahrenheit is 7 hours and 48 minutes. So we will find the time 7 a.m. plus 7 hours and 48 minutes. Therefore, we will get 2:48 p.m. For the third question, what would the temperature of the corpse be at 12:30 p.m.? We will use the same formula, but we set T to 5.5 hours to solve for T. T equals to 68 plus 14 e to the minus 0.2495 times 5.5. We will get T equals to 68 plus 14 e to the minus 1.37225. Therefore, calculate the T, we will get 71.5495, approximately 71.5 Fahrenheit.
So the conclusion, Newton's law of cooling play a crucial role in forensic science, especially in estimating the time of death. By analyzing how the body temperature changed over time, the investigator can determine when the person likely to die, even when no witness present. This provides scientific support that strengthens legal cases, help verify alibi, and assist in identifying suspects and timelines. Beyond forensics, this law also useful in fields like food safety and electronics, providing it versatility in real-life application. So in context of corpse, Newton's law of cooling help uncover hidden truths through scientific estimation of time of death. It supports justice by providing solid forensic evidence in court, give a voice to the voiceless, and speak for those who can tell their story, and brings closure to the family by answering when and how their loved one died. Ultimately, it transforms a simple physical law into a powerful tool of truth, compassion, and